All right, guys, we are going to start our fourth unit today. And you might be looking at like, Miss Golly, that's what we just took a test over. And you're right. Because this unit, guys, we're going to continue graphing our quadratics. Remember, quadratic means highest exponent is 2 for our variable. We are going to continue graphing those, but we're going to discover a different form for them today. But I want to help you, though, make the connection between the form we just did, which was vertex form, and the form we're going to do in this unit, which is called standard form. So what I want you to do is just take a couple minutes and fill in to the best of your ability that top piece. This is literally what we just tested over. Okay, so if you need calculator, pencils, whatever you need.
Do you have the weekly review 16?
As you guys fill in on your sheets, I'm going to go ahead and fill up here so you can check as you go. Again, I just want to show you that what we're going to be graphing is the same idea. We just have a different form we're using. So we have to go about our process a little different, but I just want to show you we are going to be finding the same pieces. So again, as you try it out, I'm going to go ahead and list everything up here so you can check as you go. Just be careful with your signs. This one goes left 6 and down 4. So when you get to your vertex, be careful that both are negative. Overall in our test, guys, we did a fantastic job with transformations. Overall, the tests were amazing. Just watch your signs. If we're going left, it's negative. If we're going down, it's also negative. Just be careful. There's no reflection, so you're going to open up. Since you open up, your range is greater than or equal to, and it's the y value at the vertex. So check out those pieces. Make sure those are okay. And overall, guys, finding x and y intercepts on the test was amazing as well. To find x-intercept, we put a 0 in for our y. Undo your subtraction first. Undo your square by square root. And I did see this a couple times on the test, guys, and I think that sometimes the square root of 4 throws us off a little bit when we see the square root of 4. The square root doesn't mean I'm dividing by 2. I know the square root of 4 is 2, and 4 divided by 2 is also 2. But guys, we've done other numbers besides 4. The square root of 1 is 1, not a half. The square root of 9 is 3, not 4 and a half. The square root of 16 is 4, not 8. So square root's not dividing by 2. It's asking you what number squared gives me that value. And in this case, it does happen to be 2. But that's because 2 squared is 4, not because it's 4 divided by 2. Just be careful on that. Also, most of us on the test did do the positive and negative cases with our square root, but not everybody. So a few of us aren't quite there yet with that. Square root of 4 could be 2. It could also be negative 2. So make sure you have both. So we're going to have negative 4 and negative 8. So I did not take points off on your test. If you didn't write them as ordered pairs, that's okay, as long as you had those values and as long as you graphed them correctly. I was okay with that. Sometimes writing them as an ordered pair helps us graph.
Isn't that negative 8, not negative 10?
Oh, sorry. I subtracted. I got ahead of myself. I wrote the answer instead of... There we go. Whew. I wrote the answer instead of writing negative 6. I wrote negative 8. My brain got ahead of itself. I hate when that happens. Then to find the y-intercept, 0 goes in for our other variable, which is our x. So 0 plus 6 squared minus 4. And that's something, guys, you can throw right in your calculator. Some of you did the computation. I saw your order of operations written out on your test. Kind of up to you how you wanted to approach that. And what do we have there? We have 6 squared to be 36 minus 4. We've got 32. Now, when you go to graph this, my x-intercepts of -4 and -8, those will fit perfect on our graph. -4, there's -8. Now, I would like our y-intercept to fit on our graph. Some of us on our test, and I didn't take points off on the test if you didn't graph your y-intercept because I was not specific on the directions. Some of you graphed your x-intercepts, your vertex, and you drew a nice sketch. But we really should be graphing that y-intercept as well. And again, on the test, I don't think I was specific enough to say you need to graph everything you can. So let's talk about, because this threw some of you off when there's a question like this on the review. Ms. Cahaly, 32 doesn't fit though. We can make it fit. So if I take a look, I know I have 10 spaces to go up on my y-axis. Going by 2s, it won't fit. 32, if I divide it by 2, I gotta get all the way to 16, so that won't fit. What are some other options to nicely make 32 work? What else could we go by? Can't go by 2, it won't fit. How about 4? 4 sounds good. All right, so let's make our y scale go by 4s. Let's make our y scale go by 4s. Oops, that should be a 36. Now, to make mine fit a little better, guys, I am going by 4s, but I just labeled every other line. Let me zoom in on that for you real quick. So it gets kind of crowded if I put 4 and then an 8 and then a 12 and then a 16 and then a 20 and then a 24. So I just labeled every other line. I just labeled every other line on there so it doesn't get as crowded. My scale is still going by 4s, but then it's just not as crowded. All right, so that means when I go to graph my vertex of -6, -4, I go over -6 on the x. We can keep that by 1s, but then for me to go -4, it's just down 1 box. So be careful when you change your scale. We're not only changing it to make that y-intercept fit, but then it also changes where that vertex falls as well. When working with quadratics, we're going to get some larger numbers, especially for those y-intercepts. And then for 32, that's right up here on that y-axis. And then this one, I guess we should have changed our x scale. We're 6 away from the middle for that y-intercept. 1, 2, 3, 4, we're out of space. I don't usually like going off the graph, but we want to keep our graph symmetric too. So we should have also changed the x scale to make that other point fit. That would be our better course of action than sketching it like I did up here. So everything on there, review from last unit, but again, that idea of changing the scale is something we didn't do a lot. So I wanted us to see that today. Changing the scale wasn't something we did a lot. So now I want to help you see that what we're doing next unit is not something totally different. So what I want us to do is take a look at what standard form is. In standard form of a quadratic, we still have our highest exponent is a 2. But instead of just having one x in our equation, I also have a second x. Notice in our vertex form, anytime we did vertex form all last unit, we just had a single x. It's always part of our squared term, whether it was just x squared or whether it was x plus or minus something squared. There was always just one x. Now with standard form, we have our x that's being squared, but we also have an x to the first power. So let's just take a minute and let's change the equation we just did from vertex form to standard form. I want you to make that connection so you see that when we go to graph, we're not doing something totally new, okay? All right, so to tackle this, we have to do some order of operations. Before I can do anything with the -4, I have to take care of exponents first. Order of operations says we got to do that exponent first. So, what does it mean to square something? It means that thing times itself, right? It means that thing times itself. Hopefully that's looking familiar what we did in our second unit. Now at this point, guys, the x plus 6 times the x plus 6, if you want to draw boxes, if that's your thing, if you like to split it up and use parentheses, if you like to use FOIL, whichever multiplication technique you like. So if you like boxes, draw out the boxes, do your multiplying. If you liked the parentheses, do the parentheses. If you liked FOIL, start drawing your lines and your arrows in, whatever you liked. So this is the multiplying from our polynomial unit. I know that was a couple weeks ago we ended that. We haven't done a whole lot with the multiplying since. So your choice, however you want to take care of the multiplication. So if you liked the boxes, if you liked the parentheses, if you just want to do FOIL, up to you, whichever method you liked. So go ahead and multiply those out, whichever way you like. Boxes, you want to split it up and use the parentheses. If you like just doing FOIL and you like to draw your arrows, whichever way you like. Whichever method you choose, those first 4 terms is what you should get. Or if you simplify it down. But now here's the one little catch. And I'm going to go ahead and change that color up here too. The part we can't forget though is that -4. We can't forget the -4. After we do our multiplying, there is a -4 off the end. So our final equation, x squared plus 12x, and then we have to put these two together. We have a plus 32. So the equation that we just graphed, our vertex form, we picked out transformations, vertex, we found x and y intercepts. That same equation we just graphed, we got a beautiful graph for it. We can change it to our standard form where we have the squared term, we have the term to the first power, and then, well, we just have our plain old constant off the end. We don't have another x there, another variable there. I wanted you to see that these two equations, they are the same. There's just 2 different forms. We are not always given vertex form. There's situations where we don't have vertex form. We're going to be given standard form, and we're going to be asked to graph. So we're going to start working our way through finding the different pieces. But what I want you to keep in mind, though, as we work through, this standard form equation is still going to get us that same exact graph. So we're still going to find a vertex. We're going to find x-intercepts. We're going to find our y-intercept. Just because the form is different doesn't mean our graph is going to look different, doesn't mean we're finding any new pieces. The thing that's going to change is how we go about finding those pieces. Okay, so I don't want you to see this as, holy cow, Miss Guy's unit's something totally new. It's just a different form of what we did last unit. We just graphed this equation, and now we see how it's the same as this one. It's just a different form. Those two are equal. It's just a different form. So to start us into getting a graph from standard form, I want to take this piece by piece with you guys. The first thing we're going to do is focus on the x and y intercepts. So we're not going to get the whole graph today. I want us to take this piece by piece, get really good at finding these pieces first. Then we'll worry about getting that vertex and axis of symmetry and getting our whole graph. We'll get there. So the same method applies, and that's why I had you warm up with that first question. The idea is still the same. To find x-intercepts, where does the 0 go? What does it go in for? It goes in for the y, yeah. Put 0 in for y, solve for x. Now, in order to do that, we're going to see a technique today of how we can use our factoring to solve. That's what we spent a big majority of Unit 2 doing, was factoring. And then it says to find the y-intercept, same thing we did in our last unit. Put 0 in for the x and solve for y. So whichever intercept you want, the idea holds true of what we just did. To find x-intercepts, we put a 0 in for y. To find y-intercepts, we put a 0 in for our x. So what I have today are just 4 examples, and then it's going to be your time. All right, so if we look at our very first one, I want to start by finding x-intercepts. In order to do that, our note says put 0 in for y and solve for x. And we have a little hint there. It says use factoring to solve. All right, so I'm going to start by putting 0 in for y. Let's start there. And then it says use factoring to solve. Factoring is where we spent a bulk of our time in Unit 2. All right, so in this case, we have a quadratic, highest exponent 2, trinomial, 1, 2, 3 terms, and it's just a plain x squared. The only number in front of it's a 1. So with this one, we can do our shortcut. Now, as soon as we start doing this, you're going to be like, oh yeah, this is Unit 2 stuff. I wanted to make sure we reviewed it. I just didn't want to turn you loose and say, hey, look at your Unit 2 stuff and try this out. So we can shortcut this one. So in order to shortcut, we have to find 2 numbers that multiply to give me 32, which is the last number. And they add to give me 12, which is that middle number. So multiply to get 32, add to get 12. What might work for us? What do we think? 32. First thing that comes to mind for me with 32 is 8 and 4. So 8 plus 4. Now, if you didn't use the shortcut in Unit 2, try it out. We will review the long way in just a minute. But if you can, try it out. The shortcut, guys, super easy. We need an x and an x in each set of parentheses to get our x squared. And then we keep the signs of the 2 numbers we found. We have a plus 8 and we have a minus 4. Now you might be thinking, okay, Miss Golly, so we did this in Unit 2, so what are we doing it again here for? Here's the difference. In Unit 2, so in Unit 2, we didn't have the equals 0. In Unit 2, we just had x squared plus 12x plus 32, and we were asked to factor it. Now we have the equals 0. So here's what we have to think about. We are multiplying these 2 things together. One of those 2 things needs to equal 0, and that whole side will equal 0. So if I can get x plus 8 to equal 0, this first term right here, If that's a 0, 0 times x plus 4, I'm still just going to get 0. Now also, if I can get x plus 4 to equal 0, that whole thing will equal 0. Because multiplying by 0, it doesn't matter if I multiply by 0 first or if the 0 comes second. We still get a 0. So if either that first expression equals 0 or the second one equals 0, we're in business. Now, it could be one or the other. We can't just have one of them because it could be one or the other that could make it work. So all we have to do is subtract 8. So if x is negative 8, we get a 0, and we're in business. Or if x were to equal negative 4, we would get a 0 in that second set of parentheses, and our whole right side would be 0. So we need one of the sets of parentheses to be 0, one or the other. So we find the two numbers that can make that happen. It's one or the other. Now remember, these are x-intercepts. We put 0 in for the y, and we found our x. Again, this is just a step up from what we did in Unit 2 with our factoring. Now we have that equals 0 piece. Now, if you take a look, guys, we just found these. This is our equation that we graphed up above. X-intercepts negative 8 and negative 4. We look up at our graph or even check our work, letter F. Negative 8. Oops. And negative 4. I just want to show you that we're going to get the same graph. How we get there is just going to look a little different. All the pieces are going to be the same though. So we don't always start with that nice vertex form that we're used to. Sometimes we're going to have standard form. So we still have that same process. Find x-intercepts, we put 0 in for y, and we have to solve for x. Now to find the y-intercept, guys, this takes way less work. So for the y-intercept, we put 0 in for x. We put 0 in for any x that we see. I'm just going to label this y-intercept. We put 0 in for any x that we see. So y equals 0 squared plus 12 times 0 plus 32. We put 0 in for any x that we see. What's going to happen with 0 squared? What do we get? 0. What's 12 times 0? 0. My y-intercept is just left to be 32. 0 in for x, 32 out for the y. Look at our graph up above. That was our y-intercept from up above. Again, I want you to make the connection that what we did last unit with vertex form, now that we're using standard form, we're not going to get a different graph. We're going to have all the same pieces. It's just how we get them needs to be tweaked a little bit. Y-intercept, though, that doesn't change. Y-intercept, that's just some little computation for us. X-intercepts, we're going to use our factoring for that. So let's go ahead and finish reviewing. I have our different factoring techniques within these last 3 examples. And those are the only ones you're going to have to worry about. In question 2, it looks a lot like question 1, but what's missing? How did we handle this one? What's missing for us? We've got an x squared. We have a constant, but we don't have that plain x, right? And a lot of you are busy, right? You're like, yeah, Miss Guy, remember this? This is where that 0 is missing. Yep. We don't have a plain x term. So to take care of that in Unit 2, we said, well, hey, let's put a 0 in there. Let's make it look like the one we just did. Let's not come up with a whole new process. Let's just put a 0 in there because I can add 0 to anything and it doesn't change it. So now, same process. I have an x squared. The only number in front of it's a 1. And now I have 1, 2, 3 terms. I have a plain x squared and I have 3 terms. Shortcut. Multiply to get negative 16. Add to get 0. Multiply to get negative 16. Add to get 0. These, for me, are usually my quickest ones to figure out. I know for some of you, finding the factors can get you stuck. If you still have your multiplication table from Unit 2, you may use that again. If you need to print a new one, please do so. You can use that table again this unit if you need it. If you have to add to get 0, you know you need a pair of opposites. Same number, but opposite sign. If you know you need to get 0, you have to have the same number, but opposite signs. That's why I think these are, for me, they're the easiest ones to do. All right, we've got our 2 sets of parentheses. We put an x in each one to get that x squared that we need. And then minus 4, plus 4, the order you do that in doesn't matter. What we have to keep in mind is we're looking for those x-intercepts, so we need to put 0 for the y. This is that step up from Unit 2. Unit 2, all we did was factor. We would have stopped at x minus 4, x plus 4, and said, yep, we're good. Now we have to finish. We have to find those zeros. So if x minus 4 equals 0, we'll get our 0 we need. Or if x plus 4 equals 0, we'll get the 0 we need. So we're going to add 4. We're going to get a 4 equals x. Or it could be negative 4. And these would be the x-intercepts of our graph. They would go on the x-axis. Those would be our x-intercepts. They would go on the x-axis. Your y-intercept, the y-intercept in standard form, guys, this is going to be the easiest thing that you find for your graph. To find the y-intercept, remember we put 0 in for x. Again, if you didn't use the shortcut in Unit 2, I know I had a handful of people in each class that they didn't want anything extra on their plate. Try it out this unit. If you still don't want to use it, that's okay. We're going to review that longer method next. I'm just going to go ahead and separate these out here. All right, so in a number 3, we have our quadratic, highest exponents 2. We have our trinomial of 3 terms. Now for this one though, guys, I'm not going to end up writing shortcut. Why won't I write shortcut on this one? What makes it not work? We've got a 3, right? We've got a 3x squared. In questions 1 and 2, we just had a plain old x squared. Now in this one, we've got a 3 in front. So now we don't have a shortcut, we don't have a choice, we have to do our longer process. So that process, I want to make sure I refresh you on that today. Before we do our multiply add trick, we first of all have to multiply the first times the last. So we're going to multiply to get negative 45, and we're going to add to get 4. So before I try to find my 2 magic numbers, I need to first of all multiply that number in front of the x squared times our constant, which doesn't have the x. So when I think of 45, guys, the first thing that comes to mind for me, 9 and 5. So let's see, 9, or 5 times 9, 9 times 5, whatever you want to do there. But now I need a negative 45 and I need a positive 4. So which one am I going to make negative, the 5 or the 9? The 5, yeah. We're going to do the 5 negative. Now once we have our 2 magic numbers, we're going to leave the 3x squared alone. And then the 4x splits into our 2 magic numbers. So minus 5x plus 9x, and then we have our minus 15. Now, how you did this from here was totally up to you. Some of you liked boxes, some of you liked the grouping with parentheses. Let's see. What I'm going to do is right here, I'm going to do the parentheses way, and then up above in just a minute, I'll do the boxes. So if you are like, oh yeah, I remember this, I got this, go ahead and rock it. If you're parentheses, you group the first two and the last two. The boxes, I'm just going to sketch up here, because if I sketch it, it might get you going if you use the box way. If you do the boxes, remember we start on the inside and we work our way out. So I will show both, but I wanted to show you both setups because if that jump starts you, go ahead and rock it. If you're doing the grouping with parentheses, we need a GCF out of the first set. The only thing common would be an x. So we have x, we're left with 3x minus 5. Second set of parentheses, I can divide both by 3. And we get 3x minus 5. Our two sets of parentheses match, that's what we're going for. So that becomes my GCF. After I divide, I have left an x and a plus 3. And I divide it by 3x minus 5. And then we set that equal to 0 and go ahead and split it apart. Now, if you liked the boxes, now if you liked the boxes, I'm just going to pop up here real quick. I always look at the first row first. The only thing common in the first row would be an x. And then in that bottom row, both of those could be divided by 3. First column, 3 and an x could come out. 3 and 9 can both be divided by 3, and they both have x's. Then that last row, we see that, last column, we see a double negative. So we're going to have a negative, and then 5 can go into 5 and 15. So whichever way you liked, whether it's parentheses or boxes, we get the same result. So then from here, if x plus 3 equals 0, we'll get our 0 we want. Or if 3x minus 5 equals 0, we will get the 0 that we want. If either set of parentheses equals 0, that whole product will be 0. If I multiply by 0, my result is 0. So go ahead and solve. We subtract 3. And on this one, we have an extra step. We have to add the 5. And then we have to divide by 3. So we could have negative 3, 0. And guys, you can just leave this as 5/3 if you want. If you want to change it to 1 2/3, you can. Don't make those ugly decimals though, because we will eventually be graphing those. Not today. I want us to focus on finding the x and y intercepts today. Get some practice with that piece, because this piece is going to take us the most work. Finding that vertex and axis of symmetry, it's not going to take us as much work as the intercepts will. The y-intercept, it's going to be your favorite thing to find with this particular form. Put 0 in for all your x's. And pretty soon you're going to catch on to the pattern that, well, anything with an x is going to be gone. I'm just left with that constant every time. I'm just left with that constant every time. All right, the last thing we have to refresh on, and I should have been talking about this the last 3 examples and checking for it, but I have it up in our directions. always make sure you try GCF first. And I should have been doing that the last 3. Always look for GCF first, because it might make a lot less work for you. Because right now, if I look at number 4, I'm thinking, oh man, that's like number 3. I'm going to have to do that multiply thing and do all that work. But if I take a closer look, though, all those terms can all be divided by 2. So since they can all be divided by 2, now what I have left inside the parentheses is a plain x squared. What I have left inside the parentheses, I can now shortcut. So by taking that small step of dividing by 2 first, I can now shortcut it instead of having to do all the work we did in number 3. So always be on the lookout for that GCF, because now I can shortcut. Now I can shortcut this. Multiply to get negative 18. Add to get negative 3. Now I can do my shortcut. And how much of this you write out, the multiply, add stuff, I write that out to help me stay organized. It's kind of up to you. All right, so let's see. Whoops. 6 and 3 are probably going to work here. But now which one has to be negative to get negative 3? We got to go with the 6. Where you have to be careful on this, the 2 we pulled out is still going to stay in the front. We can't lose that 2. It's not going to affect finding our x-intercepts, but I just want to make sure we stay in the habit of keeping all of our factors with us. Because someday in Algebra 2, you guys are going to graph cubics, and you might have like a 2x out front there. So I want to make sure we keep our factors. All right, so that 2 isn't going to do much for us. So if we could get x minus 6 to equal 0, or if we could get x plus 3 to equal 0, our product will be 0. Add our 6. All right, and our x could be 6. Our x could be negative 3. I like writing them as ordered pairs. As that reminder, eventually this is going to go on our graph. Y-intercept. I love the y-intercept on these. How much work you need to show on this once you get comfortable with it, I'm going to leave that up to you. Just make sure when you find the y-intercept that you always go back to the original unfactored equation. So when you find the y-intercept, I don't know if I can sneak a line in here. When you do the y-intercept, you've got to go back to the original. So don't go to where you factored it. That might get a little messy for you. Go back to the original. Put your zeros in for your x's. And again, once you get more comfortable with it, the amount of work you show for the y-intercept, it's going to be up to you. Okay? It's going to be totally up to you on that. So not a whole lot new today. A lot of review from Unit 2 with just that little add-in of we have to get either set of parentheses, the expression there to equal 0. That's really the only add-in we have today. We're going to practice this before we move on to finding our vertex.